So we're going to start here with the 2019 Calculus Free Response question number one. This was on the AB and the BC test both, so this works for both of you. First things first is if you have not already practiced this problem on your own, then you need to stop right now and go do that. If all you do is listen to me explain this question and you haven't worked through it yourself and given it your best shot, then this is not going to be very helpful for you. So if you have not done this, go back to this question. You can Google it and set your timer for 15 minutes. It's a calculator question, so make sure you've got your calculator ready. But give it your best shot on your own first before you listen to me walk through it. And that will be far more beneficial for you as you study for this exam. All right, so let's jump into it. This is a very common question on the AP test. And essentially, it's a question where they give you two rates. They give you the rate of one thing that is entering and a rate of something else leaving. This has happened in a lot of different contexts in previous years. One year it was the rate of water entering a drain pipe and the rate of water leaving a drain pipe. In this particular question, what we have are fish entering a lake. And so E of t, what that tells you is the rate at which fish are entering the lake measured in fish per hour. And then L of t tells you the rate at which fish are leaving the lake, also measured in fish per hour. Now, both of these then are derivatives. They're rates. You have them in fish per hour. And so if you integrate either of these functions, what that's going to do is going to take you from fish per hour back to number of fish. So for instance, if you were to integrate that E of t function there over a given time period, what that would tell you is how many fish have entered the lake during that time period. And then the same thing, obviously, if you integrate L of t, it's going to tell you the number of fish that have left the lake during that time period. Now, before we get to any of that, since this is a calculator question, the very first thing we're going to do is store these functions on your calculator. We've done this in class many times. If you've forgotten how to store a function, you can Google it or send me a message and I'll be happy to help you out. But these are the two functions we have stored. Important to remember that, yeah, you could use t as the variable in your calculator and that would work fine. The advantage, however, to using x is that if we want to graph either of these functions, we'll be able to graph them on the calculator without having to retype them. So using x would be my recommendation as you're doing this. Just be really careful as you're entering. One thing I recommend between the 15 and the sign is to put a multiplication symbol. Oftentimes leaving that out can cause issues, so just be careful as you're typing these functions in. Be sure to double check them to be sure you don't have any typos, because that would be terrible if you did the entire problem correctly but have a silly typo in your functions that mess up all of your answers, so be careful there. But once we have those stored, we can go ahead to part A, and it's a really simple, straightforward question. How many fish enter the lake over the 5-hour period from midnight to 5 a.m.? The one twist here is they tell you to give your answer to the nearest whole number, and people often forget that. You're so used to rounding to the third decimal place, so be sure here we do the whole number. Now what you see here is just the calculator commands. So you would integrate from 0 to 5. You're integrating the function e of x dx, and it spits out this number here, 153.457. If this were a more straightforward question where you're not having to round your answer to the nearest whole number, we would cut the decimal off here and have 153.457 as your answer. But since we are rounding, this would be the way you would present your response. The integral from 0 to 5 e of t dt equals 153 fish. And that's it. That's all you need to write in your paper. That would be sufficient for full credit in Part A. I have to remind you, of course, to be really careful with your D of t. Leaving that off could hurt you. So be sure that you are using proper notation, that you're being very careful. But otherwise, Part A here is pretty straightforward, and that should be your response for full credit. All right, Part B. What is the average number of fish that leave the lake per hour over the 5-hour period from midnight to 5 a.m.? So since we're talking about fish leaving the lake, we're dealing with the function L of t. And we want to know the number of fish that leave the lake per hour, and we want to find the average of that. So the way you find the average of any function in calculus is you integrate that function and then divide by the difference in the bounds. So in this case, our bounds are going from 0 to 5, and so the difference between 0 and 5 is 5. So we're going to integrate the function L of t and then divide by 5 afterwards. And that's what you see here in our calculator commands. So I have 5 minus 0, which is just the top bound minus the bottom bound. And let's think a little bit about what this is telling us. If you were to just integrate L of x from 0 to 5, what that would tell you would be the number of fish that have left the lake from time equals 0 to time equals 5. And then what you're doing is dividing by 5 hours. So it's going to give you an answer in fish per hour. So what this number tells you is that from 0 to 5, on average, we had about 6.059 fish per hour leaving the lake from 0 to 5. The way you'd present that answer is like this. 1/5 integral from 0 to 5 of L of t dt equals 6.059 fish per hour leaving the lake on average during this time period. So again, if you want to find the average number of something, in this case the average number of fish leaving the lake per hour, you integrate the function that has the fish leaving the lake per hour, and then simply divide by the difference in the bounds, which in this case was 5 minus 0. All right, part C is where the majority of your time on this problem is going to be spent. It's a typical maximize or minimize type question. So at what time between 0 and 8 is the greatest number of fish in the lake? Justify your answer. So essentially what we want to do is over this time period, find out when our number of fish in the lake was a maximum. Now the way max and min problems work is that you want to take the function you are trying to maximize or minimize and you take the derivative of that and set it equal to 0 to find your critical values. So in this case, we don't have a function that tells us the number of fish in the lake, so I'm going to come up with one on my own, and here is what that function is going to look like. One of the questions I get is where did f of t come from? That's just a name that I gave the function. You can name it whatever you want. F just seemed to make a whole bunch of sense. And in order to find the number of fish at any time t, what I'm doing is integrating from 0 to t, so I could plug in 2 for instance, and that would give me the integral from 0 to 2, which would tell me how many fish are in the lake at 2 hours. Now the reason that works is because all we're doing here is integrating the function e, and integrating e, we've already discussed, is going to tell you how many fish have entered the lake. And then you're going to subtract and integrate L, which is going to tell you how many fish have left the lake. So all we're doing here is saying this number of fish have entered. We're going to subtract the number of fish that have left, and that should tell us how many fish we have in the lake currently. Now, some of these problems will tell you that at time equals 0, there were a certain number of fish, and normally we'd have to account for that. In this case, we don't have that information, so we don't have any fish to start with. So we don't need to worry about adding that number here in the front. But if there were, for say, 100 fish at time equals 0, then you'd want to do 100, which is your initial amount, plus this integral right here. But since we don't have any fish in the lake initially, we don't need to worry about that. We're just going to integrate, again, e, which tells us how many fish have entered, subtract the integral of L, which tells us how many fish have left, and that tells us how many fish we currently have at time t. If it helps you, and I often do this in class, is I would write this as 2 separate integrals. You can integrate e of x dx minus the integral of L of x dx, and that's fine. You can either write them as 2 separate integrals or you can combine them. But be careful, if you combine these 2 integrals the way I have, be sure you've got parentheses around the entire expression with dx on the outside. That way dx is applied to both of these terms on the inside. Another thing to note is that we've used the variable t up here as one of our bounds. And if you use a variable as one of your bounds, you should not use that same variable again in your expression. So I've simply taken this and changed the letter. Normally it would be t, I changed it to x. It doesn't have to be x, that's just what I came up with. You can use s, you can use b, it doesn't really matter as long as it's not the same letter as what you're using here in your bounds. So if this expression gives me the total number of fish and I want to maximize or minimize this, what I'm going to do is take the derivative of that and set that equal to 0. So this is part of the fundamental theorem of calculus. When you take the derivative of an integral, essentially the derivative and the integral, those are inverse operations and they cancel each other out and you're just left with this expression right here. The only difference is that t at some point would have been plugged in So instead of e of x minus L of x, you have e of t minus L of t. But either way, that's the derivative of f, and we're going to set that equal to 0, and now we need to solve this equation to find our critical values. So we do that in the calculator. You just go on your Inspire to Algebra Solve, and you type in this expression. So we have e of x minus L of x. Remember, in our calculator, we used x instead of t. We set that equal to 0, and then we do comma x to tell it what variable we're going to solve for. We want to solve for the variable x. And then what I did right here is just to be sure it didn't give me a bunch of answers outside of our domain, I did such that 0 is less than x is less than 8 to be sure that all of the answers it gives to us are going to be in that 0 to 8 time frame, and we don't get any answers that we don't need. You can find the such that symbol by hitting Control equals on your calculator. That's also where you're going to find the less than symbols, so that should help you um, just get the answers you want to be a little more efficient. All right, so here is our critical value. And remember, what a critical value represents is not necessarily a minimum or a maximum, but just where a min or max might occur. So this is one possibility of a place where we might have a minimum or maximum number of fish. And of course, since we've got equal signs here, we have got a closed interval, we also have to check our endpoints. So time equals 0 is where a min or max could occur, as well as time equals 8. So in these problems, the way we go about this is through something called a candidates test. And all we're doing is coming up with a table. So these 3 times, these are the candidates. These are the places where your mins or maxes might occur. And then what we need to do is find out, well, how many fish are in the lake at each of those times. And so we know at time equals 0. Obviously, if you integrate from 0 to 0, you're going to get 0. So there are no fish at time equals 0. At time equals 6 approximately, we have about 135. And at time equals 8 hours, we've got approximately 80 fish in the lake. So looking at this, it's clear that this is where the minimum number of fish occurs, and this is where the maximum number of fish occurs. The way we actually generate those numbers is in our calculator, of course, by taking the function f and just plugging in our t values as our upper bound. Important here is that when I integrate, I use this entire critical value. I take all those decimal places just to be sure that the answer we get is as accurate as possible. We don't want to round until the very end if we can help it. So we get this answer here, which is the 135 in our table. And at time equals 8, we have 80. And then we want to answer the question. Now, as you answer the question, be sure you're paying attention to what they ask. They didn't ask what is the greatest number of fish. They asked at what time is the greatest number of fish in the lake. So the way I phrase my response is the greatest number of fish in the lake occurs at time equals 6.203 hours. And that is going to be the actual answer to this question. Now, always, you've got to pay attention when they ask you to justify your answer. This is one of the rare occasions on the AP test where a chart or a table will count as your justification, as long as it's got the supporting work behind it. So this candidates test here counts as justification because we've clearly shown that these are the only places where a min or max could occur. We identified this as the biggest place, and this is the time when that occurs. And so this answer here should give you full credit on part C. All right, wrapping this up in part D. Is the rate of change and the number of fish in the lake increasing or decreasing at 5 a.m.? Explain your reasoning. All right, so generally speaking in calculus, if you want to find out if a function is increasing or decreasing, what you're going to do is take the derivative of that function and see if it is positive or negative. If the derivative is positive, that means your function is increasing. And if the derivative is negative, that means that your function is decreasing. So in this case, what is the function that we need to take the derivative of? Well, the thing that we want to find out if it's increasing or decreasing is the rate of change in the number of fish. Is that going up or is that going down? So we know f of t, which we came up with in part C, gives you the number of fish. Then that means f prime of t is going to give you the rate of change of the number of fish. And this is the thing that we want to find out. Is this going up or is this going down at time equals 5? And how do we know if f prime is increasing or decreasing? Well, of course, we're going to take the derivative of it. So here is f prime. We did that in part C. We already have that on our papers. If we take the derivative of that, you're just deriving each term separately, so you get e prime minus L prime. And once you get those, of course, you want to substitute 5. And we find out that if we do that, we get negative 10.722. So we find out that the derivative is negative, which indicates that f prime of t is decreasing at time equals 5. Now, this is a calculator section. We're not doing these calculations by hand. So the way we're going to handle that in the calculator is right here. This function e of x minus L of x, that is your f prime of t. We're deriving that. We're using control equals on your calculator to say such that x is equal to 5, which is going to automatically plug 5 in for us after it takes the derivative. And there's the answer that we get. Now again, because the derivative of f prime is negative at time equals 5, that means that f prime is decreasing at t equals 5. So this is the way I would phrase my answer here. I would say the rate of change of the number of fish is decreasing at 5 a.m. since f double prime of 5 is negative, or you could also say since f double prime of 5 is less than 0. So this is my answer and my explanation all wrapped up into one short sentence. You've got to have, of course, this work supporting it in order to get credit for that answer. But that's it. Notice that when I wrote my answer, I'm borrowing the language from the question prompt. I pretty much stole it directly. The rate of change of the number of fish in the lake is, and I chose decreasing at 5 a.m. And then after that, right here is my explanation. Short and sweet, straight to the point. No extra work needed on this. It should be a pretty efficient answer there. All right, now, this is, as I said, a really common question on the AP tests. So once you've gone through this, if you feel good about it, the next step then would be to practice some similar problems. Notice that including 2019, the past 5 years have all included a question very much like this. Every time it's been number 1 or number 2, which means it's been a calculator question each of those years. If we see this again in 2020, I would not be surprised in the least. So I would definitely spend some time practicing this type of problem. All of these questions here involve rates going in and rates going out. All the same idea, all the same concept. Now each one is going to have something a little different about it. Some of them may include Riemann sums. Some of them may have piecewise functions. There are going to be little bits and pieces that are different in each of these questions, but the overarching idea of rates going in and rates going out is going to be the same in all 4 of these. So just like you did for 2019, I would get this question here in 2018, for instance, set your timer for 15 minutes, get out your calculator, and do the best you can do in that 15-minute time frame. After that, go check your answers. Whatever you don't understand from those that you can't figure out, contact me and I will give you all the help that you need in order to figure out, what you're missing on those questions. But these 4 questions should give you a really good idea of what to expect if you see a similar rate question this year on the AP test. So that's it for 2019 number 1. I'll come back pretty shortly here with number 2, and we'll talk soon.